This is Amrita SR, and my teammates are Dhruti, Harsha, and Aditya. Now we are here to present a presentation on design a database to manage stock suppliers and purchase orders. The contents contains are introduction, problem statement, entity relationship and ER diagram, schema diagram, normalization and SQL implementations, and conclusions. When it comes to the introduction, in the modern industrial and commercial landscape, the efficiency of supply chain is directly tied to the quality of data management. A specialized database system for stock suppliers and purchase orders serves as a digital infrastructures for tracking the lifestyle of goods from procurement to storage. By replacing manual logs with a structural relational database, organization can achieve a single source of truth, ensuring the interventory levels are always accurate, that the vendors' introductions are systematically documented. This project focused on designing a robust schema that utilizes primary and foreign keys to link product with their and respective sources and transitional histories, ultimately such as system minimization human error. The next slide is continued by Ashra.
Coming to the problem statements, this project has designed and implemented a robust relationship database to optimize the supply chain life cycle by integrating stock management, supply relations, and purchase order tracking. In current industrial environments, manual data entry often leads to stockouts or over ordering. This system addresses those inefficiencies by establishing clear relationships between inventory levels and procurement triggers. By leveraging the structure tables and foreign keys, constants, the database ensures real-time data integrity, seamless the vendor communication process. Coming to the ER diagrams, the ER diagram shows us about purchase order details, quantity orders, products included product orders placed by supplier details, product order details, and also the product details.
Uh, Schema diagram contain a supply table, supply ID with a primary key with a name, address, contact number, and next product table. It includes stock ID with a primary key with a description, unit price, and quantity on hand. Purchase order table records the transaction header, including IPO, POID and POID with the primary key, order date, total amount, and the supplier ID. Foreign key to link the order to specified vendor. PO details, line items table. Since one purchase order can contain a multiple stock item, this works like a bridge table, tracks the specific stock ID, uh, quantity ordered, and unit price for each item within a specific POID. Coming to the normalization part, normalization for this database involves organizing the data into three key situations: element redundance and ensure a data integrity. In a first normal form 1NF, and we ensure all tables shall contain atomic value and removing the repeating group and such as listening multiple item in a single purchase order row. Moving to the second normal 2NF, we eliminate a particular dependency by separating stock supply details into a distance table, ensuring the non-key attribute like supplier address depend entirely on a unique supplier ID rather than a specific stock item. Finally, the third normal form 3NF is achieved by removing the transitive dependency, ensuring that every non-key column depend only on a primary key, which prevents data anomalies such as losing the supplier's contact information just because a specific stock item is deleted. This structured approach ensures that any update to the supplier. Next slide continued by Dhruti.
Coming to the code implementation, when we want to create the database, we uses the create database, and our database name is management. Then we need to use a database, use management, and we want to create the four tables such as product, next supplier, and the parcel order, and next parcel order details. And the in product table we need to include the contents like product id, product name, category, and unit price, quantity in stock, reorder value. And next table supplier, like we need to include the contents like supplier id, supplier name, contact number, and email, and next address. And next table parcel order, like parcel order id, order date, delivery date, status, and the supplier id. And next table is supplier order details, supplier ordered id, and product id, and quantity ordered, unit price. And next we want to insert the values to the tables, like we want to include the table, we need to includes the values, so we uses the insert into products value. And next coming to the queries, when we want to show all the details which is included in the product, we write the query as select start from product. And when we want to display the products with low cost, we need to write the query as select start from product which is our table name, and where the quantity in stock is less than reordered value. This is our output. And next moving to the next query, when we want to display the supplier from blank Bengaluru, we need to write the query as select star from employee where the address is equals to Bangalore. This is our output. And next query, when we want to display the complete parcel order, we write to query as select star from parcel order where status is equals to complete. And this is our output. And next last query, when we want to display the parcel order details for the specific parcel order, we write the query as select star from parcel order details where the parcel id is equals to 201. And this is our output. Next is continued by Amruta.
In conclusion, the development of integrated database for stock suppliers purchase order transforms a fragmented inventory process into a streamlined data-driven operation. By utilizing a normalized relational schema, the system successfully eliminates the data redundancy of enforces referential integrity, ensuring that every transaction is accurately mapped to the correct vendor and stock item. This structural approach not only minimizes the risk of stockouts and over ordering but also provides a scalable framework capable of supporting a real time decision making and performance analytics. Thank you.